Oh, no. Speaker placement, line in
Hi everyone joining the workshop. We'll get started here momentarily. We're just getting a few last tech things figured out and getting the lighting all right here. All right, should be ready to go. Okay, so looks like we've got some people joining on Zoom. So I'll give people maybe one more minute and then I will get started presenting. So yeah, thanks everyone for attending today in person and then virtually. For those of you who are on virtual right now, we do have in-person attendance here in our beautiful new Scholars Lab in the PCL. So if you haven't come check out this part of the building yet, I'd really encourage you. And it's built for hybrid presentations, so this should be a nice location and should be good for the people here today who are able to eat donuts. We do have donuts here today, so for those of you online, you are slightly missing out, but it should be fine otherwise apart from the donuts. So yeah, those of you who are here, feel free to grab some donuts. We have a bunch, so grab several if you would like. Yeah, let's get started. So I'm going to do my best not to wander because I'm on my computer webcam right now, so I'll be pretty static here for those here joining in person. But first, to get started, I'd like to introduce myself. My name is Alex Martin. I am the new GIS and geospatial data coordinator here with the UT Libraries. I know many of you who are used to attending these data and donuts workshops are probably expecting Michael Shensky to be leading a GIS workshop, but he is now broadly in charge of research data services, and so I am the new person in charge of specifically the GIS and geospatial stuff. So yeah, if you are looking to book any sort of consultations for GIS services or wanting to go on the GIS guide or have GIS questions, you can contact me. And so let me move this screen sharing. So yeah. Today is, again, a really exciting topic. We're talking about open source GIS. So this is part of the Data and Donut series here with the Texas Libraries. And this presentation is also part of our collaboration with the new UT Austin Open Source Program Office, where we are focusing on open source software and the open source research pathway, which I'll talk a little bit more about in a second. But so, yeah, welcome to those of you again in person or online. Thanks so much for joining on a Friday afternoon. So yeah, as you know, today's lecture is both being recorded on Zoom for our folks at home and then in person as well. So yeah, keep in mind that the Zoom is being recorded and we have live audio transcription. It may not be perfect, but hopefully that's working well for those of you so make sure those captions are going. Right, and then, yes, one thing you should know is this room, since it is built for hybrid presentations, is mic'd. So if those of you in the back are chatting with your neighbors, maybe making a snide remark or two about me, those will be picked up in the recording. So just and then so yeah, we will be running from 12 to 1 with the introduction and workshop component, and then the last 15 minutes from 12 to 1:15 or from 1 to 1:15 will be reserved for any questions. But please, while I'm going, feel free to interrupt with any questions that you have. You know, I think that sort of back and forth makes for a more dynamic and exciting workshop anyway, so really don't hesitate to stop me with any questions at any point. And then, yeah, after we conclude the workshop, recording and the lecture slides will be posted online, and so you can find that on the library guide at the Data and Donuts site. Okay, and so today's workshop is the last Data and Donuts for the semester. So look out for the spring schedule that will be released soon. We're working on some really exciting, interesting topics. So hope to see you all throughout the spring. But one event during this semester that I want to advertise, I think those of you who are either attending in person or online today would be interested in our UT GIS Day 2023, which the theme is celebrating open geospatial science. So it goes really well along with our theme today. And so that's gonna run from 12 to 5 on Wednesday, November 15th. And so, you know, feel free to stop by. It's happening in this space that we're currently in right here, the Scholars Lab and the PCL. So anytime during that time frame, feel free to stop by, see what's going on. We're gonna have a series of demos, GIS professional panel. You'll have a chance to network with those professionals and other GIS practitioners around campus. There will be a series of guest speakers, including an exciting keynote speaker. We'll have a social event following 5 p.m. And then a really exciting component, we're gonna have a student poster competition. So in past years, we've had some really great student posters. This year is our first student poster competition. So there is a QR code here that you can register for that. If you're not a student or you don't want to participate in the competition, you're still welcome to submit and present a poster. You just won't be a part of the actual competition. But there are cash prizes as a part of that competition for first, second, and third place posters. And then we do have a special recognition award for posters that highlight open science practices.
Well, will any of this be available online?
Yes, yeah, so you can visit the GIS library guide, and that has links to UT GIS Day 2023. That QR code will take you directly to the poster submission process as well.
Thanks.
Yeah. All right, so to give a little bit of background as to why we're really stressing open source with this workshop and our other events across this semester, I want to introduce the new UT Austin Open Source Program Office, which we're in collaboration putting on this workshop today. And so this is I think a really exciting opportunity and service for the university community. We're offering training, consultations, a series of lectures, help desk network, along with events and publishing of best practice. And so what is really intended with this program office is to support people through this open source participation pathway. And you can see the different levels here on this diagram. And so what this does is it shows you how you can sort of progress through this workflow from level 1 of using open source software. So that's where we're really focused on today, is introducing GIS and then GIS open source software. But then, right, there are all these other levels that can really add to your research and the impact of your research, where we go from contributing to open source software and then sharing practices. So sharing your data and your code used to do your research. And what that does is really it connects you with a wide range of researchers. It allows you to get feedback, and really importantly, it allows your research to be reproducible, right? Which is really central to why we're doing research, right? Is that reproducibility aspect. And so, right, all of that then needs for your ability to advance your research and really reach a broad audience. So the UT Austin Open Source Program Office is here to support any needs throughout that participation pathway. And even if you're curious, what kind of services can you offer in my specific case? The UT-OSPO is here for you. All right, and that brings us to why open source, and specifically in this talk, well, importantly, you can access open source software free of charge, right? And beyond that, the source code is open, so you can really go in and see what's happening with your analyses. Again, it's replicable and repeatable, which is really, really important. And then you can use your open source software to share data to a wide audience that don't have to rely on proprietary software and having the necessary licenses to access your data. So you're really breaking down a barrier and opening your research up to a wider potential audience. And again, those sort of pathways to ultimately advancing your research. All right, and then the goals for this specific workshop, right? This is intended as a sort of intro into both GIS and then highlighting GIS open source software within the workshop. And so what we're specifically focused on today is QGIS, which is a common desktop application that is really globally popular and used. So the first half of this workshop, I'm just going to introduce the basics of GIS, what I think you really need to start using and exploring the software and exploring spatial data. And then the second half is we're going to go in and explore the QGIS software and get started using it. And so QGIS should be installed on all of the computers in this lab, and then at home, hopefully you have it installed, but if not, you can install it later, and this workshop is recorded, so then you can go back and follow along then. But let's start with just defining GIS, which I imagine a lot of you already sort of have somewhat of a definition in your heads, but it's pretty simple, right? So we have geographic, which means that we're relating to a specific location on Earth's surface, right? So we have some kind of spatial component, and then we have an information component. So that's what the I stands for, is information. And so that's data associated with that point in space. And so the example here, right, from Google Maps, that's probably a service that most people are familiar with, or maybe you use Apple Maps or some other mapping service, pretty similar. But essentially this is GIS, right? So we have a location, in this case, the PCL, we have a pin there, and that's associated with a latitude and longitude coordinate that allow us to locate where the PCL is on Earth's surface. Right, but then we have all these data associated with it, right? So we have a name, we have an address, we've got open hours, we have a website, a phone number, and some other data on here. We also have a star system. So that's all a part of a specific GIS. So whether or not you think about it, you're used to using GIS if you use any kind of mapping navigation services or something like Yelp, Google Maps, where you go on and see information about open, closing time, star systems, things like that. All right, so why is GIS important beyond helping you find the restaurant that you're trying to go to tonight? It helps solve geographic problems of all types. So that's an example of one, is where is the building located that I'm trying to go to? But we have a lot of other geographic problems, right? So where did the flooding occur? Or where is the flooding likely to occur? Where is the wildfire? Where should I open my business to be most effective in terms of my target customers? Those sorts of questions we can use geographic information to help us answer. And then the classic example for sort of an early example of GIS in spirit before we had any kind of software developed is John Snow's cholera map of 1854. So the question here would be, well, why are cases of cholera clustered in central London? So John Snow, epidemiologist, was interested in looking at this correlation between water pumps and where these clusterings of cholera were happening. And so what he did was plot two different variables on a map, the cholera cases and water pumps. And what that shows here is that we can see that this central pump seems to be right around where most of these cholera cases are. So this map in part was credited for helping to sort of solve, okay, which is the infected pump, and was used by John Snow going forward in these sort of 1800 epidemiology conferences to show sort of why spatial data is important. So before any kind of software, computers introduced, people were putting mapping layers together to look at spatial phenomena and how they're related through space to answer important questions. And so contemporary GIS works in a way where we're looking to take what we have in the real world, right, and put that into some kind of abstraction that we can use as an output data, usually in the form of like a two-dimensional map that's going to show our data in the way that we want it. So what's involved in that is, right, how do we take this sort of three-dimensional sphere, ellipsoid that we live on, and then abstract information from there to get our spatial understanding that we want? Well, what that takes is turning location information into raw data that's going to allow us to relate spatially, and then put that into some kind of data model that we can use in a geographic information system. And so those data models, if you're familiar with GIS, you know, vector and raster, we're going to get into that in just a second. But then what the GIS allows you to do is perform data manipulation on those data models, which can be, you know, run from pretty simple, you know, coloring the map the way you want it, to running complex spatial statistics and other analyses to get your output data. And this just is sort of an illustration showing that. So we go from our real world to abstracting that data with a data model, and then getting our output data, which in this case is census data put to Travis County. All right, so I think I'm going to talk about 3 different concepts that I think are really essential for getting into just starting to work with GIS software and GIS data. So the first one of those is GIS data models. And so I mentioned vector and raster. So that those are the 2 models that you'll work with. So vector data is going to be associated with discrete data. And so that's represented by points, lines, and polygons. So you may be able to just think of points, right, is where we're going to represent something like, say, a pothole in a road, or a traffic accident, or where did a crime occur. So, right, just these sort of discrete locations where we don't really care about like how large is that feature or not, right? We can just represent that with a point. And then we have line features, which I think those are fairly straightforward, but they would be associated with, right? So like rivers, roads, and then things like power lines and underground pipelines, things like that. And then polygon features are going to be mainly associated with boundaries. So whether those are like state, county, census tract boundaries, or things like a lake, or if you're zoomed into a map, a building footprint. But I think that brings up an interesting point where scale is going to influence how you depict features. So if you think about buildings, if you're zoomed way out, you're probably going to depict those with points, right? But if you're really focused in on a specific neighborhood, you might want to represent those building footprints with polygons. Right? So that's vector data. And then raster data is based on a grid system. So it's based on pixels. And what that's really good for is representing continuous surfaces. So any sort of satellite imagery data that you work with, that's going to be raster data. But then other things like digital elevation models, right, showing how elevation continuously changes across the surface, or land use, land cover type, right, which is continuous across the surface as well. So not discrete features, but continuous, really good at being represented by raster. But a point being made here with this diagram is you can change between vector and raster using GIS software. So it's always up to you how you want to display and think about your data in a data model. But it's generally best practice to associate vector with more sort of discrete data, and then raster with continuous data. All right, and so then the next really important concept, which,
Alex, would you like for us to offer questions as you present, or hold them until the end?
I would love if you had them while I present. I think that's
There's one in chat that's asking, how can what you showed in the last slide and discussed, how can that relate to crop simulation, as in yield forecasting based on climate models?
okay, yeah, so I think that would be probably a raster question, and the way I would think about that is using remote sensing to look at crop productivity. So satellite remote sensing, the lenses on those satellites can actually pick up beyond what we see visually on the ground. And so that means we go into the near infrared part of the electromagnetic spectrum and beyond that into shortwave infrared and others. And so what that can show us actually is the photosynthetic activity of vegetation. So I would think about using those satellite remote sensing images that can show us vegetation activity and using those as raster scales. And yeah, I would say that usually climate models would also be raster data. So you would do some raster-based analyses, I think, to relate the sort of crop productivity with climate models. Okay. And then, yeah, Jennifer, if you wouldn't mind, if there are follow-up questions on the chat, let me know. But yeah, no, thanks. That's a really great question. And yeah, I mean, I would be happy to talk personally with the question asker. I have quite a bit of experience in the remote sensing realm, so I would be happy to cover that in more detail. But so moving back to these important concepts as we get started with GIS, layers, right? So we looked at that John Snow map of cholera cases, right? The real value of that map is not just showing the cholera cases, and it's not just showing the pump locations. It's when we combine the two, we can see that spatial relationship between where those cases of disease are happening compared to that infected pump. And so that's why layers are so important. It's because when we're able to show different variables together spatially, we can view these spatial relationships. So these examples here show a mixture of raster and vector layers and sort of what they would look like stacked on top of each other, because that's exactly what we do in GIS software. Is we work with different layers of spatial information, and we look at relationships between those layers and among those layers. So you can see here we have land use, which is a continuous layer. So raster data, elevation, raster data, parcels, polygon, vector data, streets, line vector data, and then customers, which are these points data. So in this example, we may be interested in, okay, why are our customers located where they are? And that may have to do with where the streets are located. Where the streets were built likely has to do with parcels and then elevation. And of course, land usage is going to tell us, okay, well, if we're looking to appeal to those target customers, we may have to look at zoning information associated with land use. So you can see how those different layers work together to maybe show, okay, well, if we're targeting these customers, then given all of these different sources of information, where do we want to build our business? All right, so we have data models that we covered, vector versus raster. We have layers, right, where we can see important spatial relationships by looking at multiple layers. Now we'll get into something that's a little bit complicated. If you take an intro to GIS course, usually spend about a week at least learning about coordinate reference systems. So I am going to try to condense that into just like a minute long spiel here. And the good news with contemporary GIS software is to just get started working with layers and looking at spatial relationships. A lot of times you don't need to worry too much about this. They'll do on the fly projections for you. It's when you start to do precise measurements and get sort of aerial in terms of area measurements. That's when you want to think about what sort of map projection are you in. we'll talk about why that is very quickly. So we start with a geoid, which is a complex representation of the Earth in a three-dimensional model with elevation worked in. And then from there, we do a mathematical transformation to a simpler ellipsoid. And then, so that allows us to just drape a coordinate system across Earth, which you'll be familiar with, latitude and longitude, right? So that gives us then spatial information where we are on Earth, what is our location compared to all other locations on Earth. So then the tricky part is the projection, and that's where we're going from our three-dimensional understanding of the Earth to a two-dimensional understanding. And so that requires a map projection, right, where we're taking this three-dimensional object and we are projecting it onto a 2D surface. And so that process requires some kind of abstraction where we are going to be changing and distorting distance or angles or shape in some way. So there we have to pick and choose depending on what we're using the map for, depending on the information we're interested in, what do we want to distort and what do we want to keep accurate. And so that all depends on the map projection. So as you continue to use GIS, that's something you should definitely be aware of. It's a little complex, so we're not going to worry about it today in the workshop. But I think those are sort of the three base kind of concepts that it would be good to be familiar with as you start working with the GIS software and spatial data. All right, so now that we have those sort of basic concepts introduced, we move into the software, right? Since we're talking about open source software specifically, we should take a step back and we can kind of look at the landscape of general GIS software. So we have mapping and analysis. This is going to be probably the most commonly used software for people who are just general GIS users. And then we get into scripted processes and analyses. So this is Python and R for people who want to automate and have really reproducible workflows of GIS data. And then you can see as we move on, there are more kind of specialized GIS softwares for different things like using LiDAR data, photogrammetry, architecture engineering. And this is by no means a comprehensive list. There are a lot of specific remote sensing softwares, things like that. So in this context, I want to revisit again, why is open source important specifically in GIS? And so I'll quickly tell a story of when I was an undergraduate student. I was focused on geography, and this was at a different university, and all the classes were required to be taught using Esri ArcGIS products, which is sort of the dominant proprietary GIS software in the US. And so then, I gained skills specifically in that software and graduated and immediately lost access to that software because it's really expensive. And so, there are institutional licenses, and while you're here at the University of Texas, if you're a student, I would encourage you to take advantage of that and get some familiarity with Esri ArcGIS Pro, especially because that is still somewhat the standard in the professional GIS market in the US. But I would say that anything that ArcGIS Pro can do, open source, can pretty much match that, and oftentimes exceed it. And so some of the really advantageous things with the open source GIS softwares are they're globally popular. So if you're working internationally, collaborating with people at a different institution, if you're using open source software, you don't have to worry about licenses, right? And again, the reproducibility aspect of it, if you have people reading your research in a different country and working with that, they'll be able to access the same analyses that you performed if you're doing that using open source software. And you may notice I'm using Jennifer.
When we were talking about the various facets of types of software that you can use in doing this work, you mentioned Python and R.
Yes.
And the question here in chat is one better than the other when you're trying to use something like that for GIS work?
So my next slide actually covers that. So well done in anticipating exactly where I'm going to the person with that question. Yeah, and so just the very last thing I want to cover on this slide is that unlike ArcGIS Pro and the Esri softwares beyond their online softwares, they are specific to PCs. They won't run on Macs. Whereas QGIS and then things like R and Python, they will run on Macs. I'm doing this demo today on a Mac, and you all have access to QGIS on those Macs. So there's another reason if you use Macs and you work with people who use Macs, QGIS can be used. So talking about this sort of landscape of popularity, you can see in the US, and there was just a change where the ArcMap desktop software was the main Esri software until about 2020, and then ArcGIS Pro is the new sort of Esri standard software that's being introduced. So you can see that popularity change here. This is from Google Trends, where you can just compare Google history to get an idea of popularity and usage for things like software. So you can see here in the US, there's still a popularity advantage for ArcGIS Pro, but when you think about things globally, it's no contest at all, right? QGIS is extremely popular globally compared to the Esri softwares. And if we look at the map, the US is actually the only region in the world where, according to the Google Trend data, at least, ArcGIS software is more popular than GIS. So keep that in mind as you think about sort of what audience do you want to have the capability of reaching, and who do you want to collaborate with. All right, so now on to the question in the chat. This is exactly what this slide is looking at. So what's the sort of difference between using Python or R to automate GIS processes? And there are answers that Python is particularly good at certain things and R is particularly good at certain things. But what I would say is it really just depends on what you have experience with and what you're more comfortable with. What's less intimidating to get started with. I tend to use R. I have a lot of experience with R, but our other GIS expert within research data here at the library is Michael Shinsky. I know he's big into Python. So even people have just their different softwares that they use. And then I just have a list here of some important GIS packages in R and Python. So if you're interested in this stuff on GIS Day on November 15th, I'm giving sort of a second part of this talk where instead of demoing QGIS, I'm going to demo R and Python for GIS workflows. So if that interests you, you can stop by then. Or if you're thinking, well, I don't want to listen to this guy talk anymore, then you can skip that and attend the other sessions that day. But an example of why it's nice to script your workflows is you can do the complex mapping and things that otherwise take a lot of time in just a few lines of code. So this is displaying census data for Travis County in just about, say, like maybe 10 lines of code, not counting loading the different libraries. And a lot of that is just assigning on lists, like aesthetic choices. So like the color ramp and things like that. Whereas if you're doing this by hand, you have to go online, you have to find the census data, then you have to find a shape file to attach the census data to. And then, if you wanted to do that for a different area, you have to go and redo that whole thing. But if you have it all scripted, it's reproducible, right? So if you want to do this for a different area, and you just change up one line and run it. All right, but let's get back to QGIS and let's get going on the actual workshop and hands-on. So one thing to keep in mind, QGIS, when you install it out of the box, it comes as a pretty nice, nifty, lightweight package, but then it's really pretty much endlessly customizable because people contribute plugins. And if you're an active advanced user, you can also contribute your own plugins as well. But if there's sort of a customized research process that you need to perform in QGIS, chances are that there's a plugin written for it. And if not, then you have the chance to go ahead and either request that plugin in the user community or write that plugin yourself. So the plugin world of QGIS is really exciting and customizable. All right, So getting in our tutorial here, we're gonna work with open data from the Texas Geodata portal, which we're really proud of here in the libraries. And then we're going to load those data as layers into QGIS. We're going to query vector data, we're going to clip raster data, and if there's time, we'll produce a nice little map. And so what we're going to be working with today is data that shows Pancho Villa's locations in Mexico during the Mexican Revolution. So if you're unfamiliar with Pancho Villa, he's an important figure of Mexican Revolution. He had himself and troops that he drove around in his own personal train during that time, and used it as sort of a Trojan horse in some cases, and just as a real sort of important strategic tool. So we're going to compare data from the Benson collection that's provided through our Texas Geodata portal that shows locations of Pancho Villa's correspondences during that time. And then we have historic maps of Mexico from 1933 that is from the Army Mapping Services, where we can actually look at some of those old railroad lines and sort of match up how his movement corresponded with those railroads. All right, so if you want to go ahead and on your machines, open QGIS. So I'll show you what that looks like. I'm a little zoomed out on these windows, but you can see it's sort of this Q logo here. And so go ahead and open that on your computers here if you're following along with the live demo. If not, just sit back and you can do this later with the recording. And then, while that application is loading, we can go onto a web browser and go ahead and navigate to the Texas Geodata portal. All right, so I just Google it and you can find it that way. See a nice little picture of me on the side here. And then you can just go ahead and click on the Geodata portal here, and it'll take you to a page that looks like this. So I can just go and click on the Benson Latin American collection, and I'm actually going to, I can clear that then selection here with an X. So if I'm exploring the data and I get into a specific place, I can just X out of that and come back to this main page. I'm going to sort here by institution. So we're working with our own data today from Texas, but you can see there's a list of different institutions providing open geospatial data, which open data is really important, right? When we're talking about this idea of open source software and this open source participation pathway. So, as you're thinking about if you're producing data, think about, how open you should make those data. All right. And so we're in our specific Texas collection here, and now I'm going to navigate by place, and I'll just select our data from Mexico. And so here now, on the last page, I'll be able to find those Pancho Villa data. So I can click on that and get a nice preview in the map viewer of what those look like. So, right, these are our point features vector, and we're going to download that shapefile. So shapefile is going to be the common file type that you use with vector data. All right, and now we're going to make sure that downloads, and I'm going to go back, and now I'm going to do one of these Army Mapping Services maps we can go down here and check what year these are from. So 1933. So we're a little bit off in terms of timing with the Pancho Villa data from that 1913 to 1915 range, and then these AMS maps, which are 1933. But with historical data, we sort of use what we can get, and this is still better than using some sort of contemporary, railroad lines, which may have changed. So here we can do the same thing, download, and notice that's a different file type, because now we're working with raster data, because these are scanned historical maps. Now I'm just going to download one more of these AMS layers. Let me find it here. Minez, here we go. So Again, I'm just gonna download those data, and if you saw those points, you'll know, okay, just these two maps, we're not gonna get all the coverage that those Pancho Villa locations were for, but this will give us a nice selection of where those locations were in relationship to the railroads. All right, so now in my downloads here, you can see I have these folders that downloaded. Yeah.
Can you repeat which ones we have to download?
Yeah, so it's Torion, which is on the last page there, if you're specifically in the Texas data, and then specifically in Mexico as a location, that's gonna be the very last page on there is gonna have both the Pancho Villa locations and the Torion raster map. And then for Jimenez, that is on the second page here. So that's what these files look like. Okay, so now that I have those downloaded, you can see if you're using a PC at home, those are gonna come as just a zip file, and you'll need to extract those. So using either extract here or designating where you want to extract those files to. On Macs, it should either automatically unzip those files, or you just have to double click. And so you can see those come in folders with multiple files in here. And so what these are we have one main file. So in the case of the raster, that's going to be this JPEG file. And then these other files in the folder are supporting spatial and other data information that main file calls upon. And so with the shape
Alex,
file,
we can't see the other folders or the folders. We're only seeing the browser,
oh,
at least on Zoom.
sorry, yeah, we're not we're seeing it okay in person here. So thank you for that. Go to my desktop one.
There we go. Great, thanks.
Yeah, thanks for the heads up. So here we have our folders, and you can see we have multiple files within each folder. But so just know it with vector, with the shape file, you're gonna look for these SHP files are gonna be the important ones. And then with the raster, it's either gonna be a JPEG or a TIFF or a few other formats depending on your data type. But now let's get into the actual application here. So my QGIS is open, and this is what your welcome page should look like. I may be in a slightly different version than those of you in the lab here or at home, but it should be fairly similar. So I'm just gonna open a new empty project. And so this is what the main QGIS interface looks like. So we have, starting at the bottom left here, this is our layers menu. So as soon as we load in those data that we just downloaded, those will populate here on the layers menu. Here is our browser window where it's going to store certain plugins, and will also allow us to access some folders here. So if I wanted to download data using the browser, I could, but my folders have a ton of files. This is an old computer. So to add data, I like to go up here into layer and add layer. And so here you'll notice you need to know if you're working with a vector layer or a raster layer. So let's go ahead and add those Pancho Villa locations first. And now this is the load data sort of start screen. And I can go in here where it says vector datasets. See this box with the 3 dots? If I click on that, that's going to allow me to browse through my folder content. And so I'm just going to go to my downloads where my data are stored, and I'm going to search out these via correspondence data sets. And now you can see here are those different data sets, and you can see this SHP file is what we want to load into the software. If we wanted to limit it to just that, I could change where it says all files down here to just Esri shape files, and you can see now that that's the only one populated. So if you're confused by all the different data files on there and know that you're looking for a certain type of file, that can be useful. So I'm going to go ahead and open that and add that to my map. So this is, as mentioned before, right, projections, they are definitely important. Here, we're just gonna be okay with the on-the-fly projecting that it's doing. You may get a slightly different message than mine, just based on maybe some different background settings I have, but you can generally just press OK. And then close that out. I accidentally added 2 layers, so I can actually right click on one of these and I can see all my options, and so I can just then remove a layer. All right, so now I have my Pancho Villa locations. We'll look at that. We'll look at those data in a bit. To start with, I may want to add a base map. So over here in the browser, where it says XYZ tiles, I think that the versions downloaded, at least on these Macs in person here, should have some options under XYZ tiles. I probably have more options than you do for base maps. I'm just going to use OpenStreetMap here. And what a base map is some kind of layer that's helpful for showing our location of our data, but that we're not going to be able to perform like analyses on, and we're not necessarily going to be able to change details about how those data are displayed. So you can see now with the way my layers are ordered down here in their layer menu that I can't see those points anymore. And that's because OpenStreetMap base layer is located above my Pancho Villa points. So I can actually drag that up above there now to show the data points above the base map. So that's just a sort of very basic illustration of it's important to have your layers ordered in the proper way. All right, and so now I want to add my raster data. So again, you know, if you prefer to navigate to your files on this browser window, you can totally do that, but I'm using this layer and then add layer option. And now for those AMS maps that we downloaded, right, those are scanned historical maps. So those are raster data. So we're going to add raster layer. And it's going to be very similar to how we did the vector data, where we're just going to browse. And I can go back to my downloads folder. And now I can download my Torreon layer, and apologies for my bad Spanish pronunciations. Open that and add that layer to the map, and we can move this window and verify that that was indeed added. And now I can X that and go back and add my next layer here. So again, downloads and then Jimenez folder. And the same thing, if you get confused by all of these different files within the folders, and you know, okay, my raster data that I'm looking for is JPEG, and you can change this all files to be either all supported files, which is going to narrow it down to certain ones. But then if it's even better if you can do your specific type of data that you're interested in. But here, I know it's the JPEG, so I can maneuver down to that. And one of the hints you get is just the icon on your computer. At least mine is showing that, right? It looks like an image. So I can open that and now add that. All right, so I mean, that's a huge part of the GIS workflow, is locating the data you want, downloading it, and then getting it into the GIS application. So we're a far ways here, just getting our data in here, because as you can see, we can even now, before we've really done anything in terms of processing our data, we can see that there does seem to be a spatial relationship that we're interested in, right? Which is these Pancho Villa locations with these railroads. And so we can zoom way in here to see the detail and what the railroad looks like in 1933. And you can see, National Railroad System of Mexico is this sort of dashed line along here. And then I'll zoom out a bit again so we can see then where those points are located. And to zoom in and out, I'm just going up on the top bar here and selecting these pretty straightforward, zoom out magnifying glass, zoom in magnifying glass. Now I can hardly see those points, so I'm gonna start by going on to my layer options here by right clicking on my layer and hit properties. And so that's gonna bring me to a whole nother menu where I can do lots of different editing with my layer here. And so I'm going to change this symbol to a nice big white dot and press OK. And now I can see those points a lot better. But so that the next thing we want to do is these locations represent a lot of different data types. And the way we can go and see what those data types are is by going to the attribute table. So that's where all these information about the points are stored. And so that's vector data have attribute tables associated with them, and they can range from really simple tables, which just have a few different columns to massive tables with tons of information. So this one you can see, right, we have quite a bit of information. We have where these correspondences coming from, where are they going to, what's the date of those correspondences, and so on. But what we're interested in, right, is specifically Pancho Villa's location. And so you can see under point type that we have Villa location here. And so those specific points are going to tell us where his recorded locations are within this data set. And so we want to extract just those points representing his locations. So one of the ways to do that is we can use this select features using an expression. And here, right, it's a long and complicated looking list, but if you go to fields and values, that's going to show us all those different fields from that table. So I can go and see point type and see that's highlighted. So that's where I want to use to extract data. So I'm just going to double click on that, and you can see it activated that in this other window. So point type, and if you look at this window to the right here, I can load all the unique versions of that, and we just want via location. So I can go in here and just do equals and then double click on via location. And now if I press select features, you can see it's selected 612 matching features. So now I can X out of that. It's going to keep those highlighted. You can see those highlighted points here are now turned yellow. And now if I go back to that layer, and again, I right click on it, I can choose export. You can see here, save selected features as. If I select this option, that's going to allow me to create a new layer with just those selected points. And so now I can navigate to where I want to save this file. So maybe on my desktop, and I want those, I'll just call it V locations. Save. And I can leave the rest of this just the way it is and press OK. And you can see I had a little checkbox down the bottom that's by default activated, and that's add layer to the map. So I can see that layer was automatically added. So I can now deselect my original shapefile, and now I just have my Pancho Villa locations. And so I'll go in here and change the symbology again to a white dot. Press OK. All right, and so now what we want to do is we want to make these historic maps a little bit easier to deal with it and communicate better, right? Because the way we have it now, we have these big sort of white borders that are complicating our ability to see this sort of movement with this railroad line here. So with raster data, we can perform what's called a clip, and that allows us to define some kind of boundary that we want to clip that raster to. So if I go on to my raster menu and extraction, I can clip by extent. And here, I think what would be good to clip is this bottom part of the Jimenez map. And I actually have to be careful of my order here. So I want to see where that ends. So I'm going to put the Torreon map above that so I know where to draw my clipping polygon. And then since I'm drawing, I want to make sure that I have a good extent to draw from before I open up the raster clipping menu. So here I'm gonna go on and extraction, so raster by extent, and here defining here, I can select draw on canvas. And so as soon as I move that out of the way, I can now start drawing my shape, and I'm just gonna go right down below where this gray border is and be satisfied with that. And now I can press run, but one important thing to keep in mind is on certain functions like this, I have the option of saving this as a file or just creating a temporary file. So if you actually want that file to stay on your computer after you close your document, you need to save that as a file. For this is example purposes, I'm just gonna save it as a temporary file and run. See how long it takes to run. Close. Let's see if we like what this created. So I'll bring this up front, and there we go. So now we got rid of that gray box. Zoomed out, you can sort of see where the maps change, but if we zoom in, we can see how good of a job whoever scanned and georeferenced this map did, because look how perfectly these railroads align here on these lines as we transfer from one map to another. So these are really nicely aligned. And now just quickly to wrap up this demonstration, I want to show you how you would actually make this map like as a map that you could distribute and share with a title page and cartographic elements like a north arrow. So I go to project and then new print layout is how I'm going to go make that document. I can give it a name. So via locations. And okay. And so now I'm presented with a page that looks like this. I can navigate on the left here to add map. And so that's going to allow me, and if I was really serious about this project, I would take a lot of time thinking about border width and stuff, but I'm just going to draw now on here where I want my map frame to be. And for time's sake, I'm just going to say that looks okay. And now look, it shows what's in my map viewer here in this new window, which is going to allow me to add a title page. So I can go over here. This is add label. So I can go in and add, something like Macho locations, and I can go down here and change the font size because it defaults to something pretty small. So now I have a title. I can add my scale bar. So that's over here, also to the left, and draw that on my map. Now I just think it's a good cartographic principle to choose round numbers on your scale bars, so something like 50 kilometers versus like 45.6 kilometers. And then another cartographic principle that we always want is a north arrow. And so I could draw that, and if I wanted to be picky about what my north arrow looked like, I could go in and choose a different image type. So for example, I could choose this instead. And then so other important components that I won't spend time showing are, so you can add your legend here, and then again over here in the editing toolbar, you can sort of edit what is included in that legend, what's not, how do you label those legend items. So once you're satisfied with your map, you have your title, you have your cartographic elements that you want to include, you can go in here and export as image, and they give you some kind of warning system or warning message, but then you have the option to save as a number of different image formats. And so there you have the workflow from downloading the data to finishing your map. So now I will go back and wrap up quickly the presentation. So go back to. There, here. And just as we finish up, I want to reinforce that we offer lots of GIS services. So if you're interested in learning more about what you heard today, or advancing your technique or using a different software, we have lots of resources to do that. So we have our UT GIS library guide, where there's all kinds of helpful information from guiding you on how to use software, get started with Python and R for GIS, navigating you to lots of different data sources, and also information about upcoming events like GIS Day on November 15th at noon. And then, yeah, keep an eye out for our spring data and donuts schedule, and you can schedule personalized consultations online, also on that library guide. Always happy to sit down on Zoom or in person to talk about your personalized GIS questions and research. All right, so just wrapping up here, I again want to mention, so this is done in collaboration with the UT Open Source Program Office. And so, if you're really interested in this idea of open source data and really pushing your research to be replicable and to reach a wide audience, they offer resources to do those things. And then again, UT GIS Day on November 15th. The student poster competition should be really exciting, whether you want to enter it or attend it. If you're here getting the introduction, maybe you won't have a poster ready for November 15th, but keep that in mind. You may want to come and see some posters, and think about that for next year if you're just starting your GIS journey now. But yeah, thanks so much for attending. My name again is Alex, and you can find me online on the UT GIS library guide. So thanks very much. Right, so now, yeah, I think as promised, we have some time for any questions that people have virtually and in person. And again, for those of you in person, grab some donuts. You can take some with you, because if I'm left with a bunch of donuts, then yeah, it's not gonna be good.
What are some of the main focuses of the geographical community for GIS data?
So by the community, so the online library guide.
No, I meant the research at UT Austin.
Oh,
What are some popular themes?
Yeah.
Research.
So it is amazingly diverse, the UT GIS community at UT. We have spans from departments in the sciences to the humanities and everywhere in between. We have lots of exciting work with really high-tech stuff like LiDAR and other three-dimensional rendering systems. We have people doing really interesting remote sensing on Earth, but also in space. We've got people doing really interesting sort of qualitative spatial tours of the university campus, along with sort of and virtual components along with those in-person tours. So that's just to name a few. I mean, it's really varied, and it happens across a bunch of different departments.
Thanks.
Yeah.
So Esri, I saw that Esri had an ArcGIS Urban tool, and it would allow you to go in and see like a project that was saved, kind of like a cloud it looked like.
Okay.
Do any of the other tools work like that, or would you have to save and share the way that you did just a few minutes ago?
Oh, so in terms of a cloud system, so definitely Python and R have access to different sort of online systems of storing and sharing your data. And then QGIS, I haven't worked with it personally in a cloud capacity, but I would imagine, and you can look for yourself in terms of the plugins for QGIS, there are ways to get that working in some kind of cloud. I know there are plugins specifically that work with the huge, massive remote sensing data storage that Google has, which is stored on the Google Cloud. And so you can directly access those data through QGIS using a plugin. So I think sort of, I talked about the customizable nature of QGIS using those plugins. You know, you should be able to find what you know would work for you and what you're interested in. And then if, you know, if not, you can flag that that's, you know, would be a useful tool on the QGIS community, and you know, you're likely to get some uptake on that.
Perfect, thank you.
Yeah, of course.
So I'm pretty new to just GIS, so it's my first workshop at all. In the exercise that we did, I saw that we come out with a map that's kind of like static, like that it's fixed.
Oh, yeah.
I'm asking, so my question is there outcomes from the software that's manageable? And
Yes.
people can interact with?
Yes, and so that has to do, so there are lots of opportunities to create web-based maps where people can go navigate and have an interactable map where they can explore the data. And yeah, so that's a method of, you know, sort of publishing web maps. And that's another thing that I think R and Python are both really well suited to producing. Leaflet is the main program that I'm familiar with that's really useful for just producing those interactable maps from a few lines of code. So for instance, like the census data map I was showing to you, using Leaflet and a few extra lines of code, you could turn that into something where a user could go and select a census tract, and it would show them like the statistics associated with that census tract.
What's the name of the function?
Leaflet. Yeah.
So how do you incorporate this like coding software with the GIS like interface?
So there are a few different ways. So you can integrate Python coding directly in QGIS. And if you're interested in doing that, feel free to contact us. But there's also a part of the UT library guide that'll show you how to use Python with QGIS. But you can also do it standalone in either Python and R. And it's just a matter of downloading the packages that do that. So we'll go back to this package list here. Yeah, and so these different packages are going to give you lots of different GIS capabilities. And again, yeah, for example, so the leaflet is on here. And so that's for, you know, if you're interested in creating interactive web maps, right? But, you know, so there are specific, if you're interested in working with census data, there are specific packages for both Python and R that are bespoke census packages that allow you to go in and produce a map really smoothly and easily. So yeah, I mean, I think if you're interested in that, you know, it's always, well, yeah, you were in the Google Earth Engine class. You know, coding can be a little bit intimidating at first, but once you get going with it, it's not too hard. And a lot of it is just copying and pasting code from like Stack Exchange or different online forms, and then, you know, changing around to suit your needs and your data. So what can seem intimidating at first is actually, I think, can be pretty easy to uptake, and then it'll save you so much time in the long run automating processes. Like, I don't know if you've ever gone through the trouble of downloading the census data, attaching that to a shapefile, you know, and then, you know, working with all those CSVs and other things. That whole process is so much easier in R or Python than it is to do it with something like the QGIS. And I will take that opportunity to again mention that on GIS Day, I will be doing an R and Python version that's similar to this workshop of sort of getting started with doing GIS in these programming languages.
Oh, and Alex, there was a question in the chat asking if is there a particular resource that you recommend for getting more familiar with QGIS?
Yeah, so I'll go with two. You can start at our UT Library Guide resources for QGIS. I'll always default to those. But there are a number of official like QGIS hosted forums online that have all kinds of questions and also tutorials. Because it's open source software, there tends to be a lot of free open tutorials and information at your disposal, right? That's one of these really big selling points of the open source software is you're connected to this really wide user community who really cares about making sure that things are open and accessible. So yeah, I would start with the UT Library Guide, the official QGIS tutorials, and then from there, I would say, if you have a specific thing you want to learn, Google that, and I bet chances are you'll see Stack Exchange information, you'll see QGIS specific forums that will be really informative. Great. Do we have any more questions from the virtual audience? Sounds like maybe not. So if that's the case, I may take the chance to go have a donut. And I hope everyone has a great weekend. It is nice to have such an engaged audience, both online and in person, for my first Data and Donuts workshop. So again, we're here. We have lots of resources. Always really enthusiastic to help anyone from the campus community with whatever their GIS needs are, or more broadly, their open source needs as well. If it's not specifically GIS, don't hesitate to reach out to me or Mike Wolszensky and anyone else at the libraries and the open source program office as well. Yeah, hope everyone has a great weekend, and we will be on the lookout for you all at our events moving forward. Michael, am I good to end the Zoom?
Yep, I think we can go ahead and end it. Thanks, Alex. Great job.